For this given circle N, we are to solve the values for unknown measurements X and Y. X here corresponds to two different lengths of measurement, but of the same value. First is for this segment from this point on the circle towards the point or the exterior point where both of these second segments originated. The second one is the length of this chord, which is also part of this second segment. Once we could locate or give the relationship between the two different segments represented by the same variable x, we can solve for the unknown. And consequently, the value of x may be used to solve for the value of y, since y pertains to the entire second segment here from this point to that point, which involves the value of x. So whatever the value of that, by segment addition postulate, add it to 20, you will get the value of y. First, let us solve for the value of x. X here again represents these two different segments, but they are actually part of two different second segments, this second segment and this second segment here. And for this, we are going to use the Secant-Secant power theorem. This is actually in concern with the measurements of segments from two different second segments that are actually drawn from a same exterior point. And that is actually that theorem tells us that the product of the measurement of the entire second segment here, again this second segment, not just 20 because that's just a chord. So the entire second segment, let us just use here x plus 20, or 20 plus x, using commutative property is just the same. So the entire second segment times the exterior segment, which is x, is equal to the same concern on the second segment form. So you have the entire second segment, that's x plus 8, that's 8, times the exterior segment here, which is 8. So this is an equation that we are going to use to solve for the value of x. And of course, you were expecting to distribute that as well as here. This is 8, by the way. So you will have here x squared plus 20x is equal to 8x plus 8 times 8, which is 64. Okay. And with this equation, manipulate it by transposing it to the other side. You will get x squared plus 20x minus 8x. That's minus 8x minus 64 equal to 0. And we will have here a quadratic trinomial, x squared. You will have here plus 12x. And you have minus 64. Again, 64 equal to 0. Okay? And we are going to factor this out. So if I'm correct, we are going to factor this out. So we're going to factor this out. You have two factors here, which is equal to 0. So you will have here x, and this is x here as well. So we have negative 64 factors of it. That will get, what they call this one, 12 is plus 16 and minus 4. Let's try to check by using FOIL method. X times x is x squared. X times negative 4 is negative 4x. 16 times x is 16x. Minus 4x is 12x. That's correct. 16 times negative 4 is negative 64. Let me increase it here. For we are going to use here the zero factor property, which will allow us to equate both factors to 0. So your first value of x is negative 16. For the second, x minus 4 equals 0, you will get a result of x equals to positive 4. These are the two values of x for our unknown, but we are going to accept only the positive result since x is a measurement of length of the segment, exterior segment here, and this chord, so we don't accept negative values. So this is actually 4. This is also 4, though the figure is not really accurate, but let's try to check whether if our answer is correct or not. So let's try to multiply the value of the entire second segment. So 20 plus 4 is 24. Multiply it by 4. 24 times 4 is 96. On the other side, since this is 4 plus 8, you will have 12 times the exterior segment. 12 times 8 is actually 96 as well. 96 as well. This is actually correct. The value of x is 4. Now for this, since we know now what is the value of x, we can now solve for y. Y is the sum of 20, which is this chord, plus the external segment x given to us by 4, because this is the entire second segment, and hence y is 24. Before I forget, since we don't have any unit of measurement, we simply place here units as well as here for units for x. These are the values of x and y for this given circle N.